Mike, the 14 digital shaman, the Lord of Ord. Go do some more reading for nobody else but myself. Synchronicity, Science Smith, and the Trickster. Anyways, Combs and let's just see, Combs and Alan Combs and Mark Holland. And maybe the reading's only for myself. If so be it. If that's the case, not much you can do about it, and I admit that I'm not any good at it, but that's not what it's about. Introduction, Science, Myth, and Nature. Pythagoras. So Pythagoras, it was said, could read the meaning of ripples of water stirred by the wind. He evidently believed that seemingly random events in nature form a common fabric with events in human lives. This may seem odd to us, but such a belief was not unusual in the ancient world. The Chinese, for example, read answers to questions scratched onto smooth pieces of bone or tortoise shells by examining the random patterns of cracks produced when these objects were placed in a fire. In fact, the notion that the cosmos is formed by a single common fabric, which includes both the worlds of nature and of humankind, a fabric in which each event, however insignificant, is connected to each other event, and varying forms remained with us up to the beginning of the modern science. In classical times, for instance, Hippocrates, said, there is one common flaw. One breathing, all things are in sympathy. The great principle extends to the extremist part, and from the extremist part, it returns to the great principle, to the one nature, being and not being. In the Middle Ages, people believed in a creation in which God played a role in all things, no matter how small. All events were touched and harmonized by this divine purpose and consent. In the late medieval world, the various levels of the cosmos, the earth below, the celestial spheres above, and the human soul were thought to be brought together by mutual harmonies or sympathies. Events in one were reflected in the other. For the inhabitants of the ancient medieval worlds, the cosmos possessed the properties of a womb. It enclosed one entirely, supporting and carrying one forward through life, in a fashion which, if not always comfortable, was at least meaningful. In the 17th century, this state of affairs was shattered utterly. The force that shattered it was the relentless hammer of mechanistic science. Mechanistic science was founded on the belief that the universe is composed of small, unyielding, solid objects, atoms, and floating and interacting in an absolute void. Democritus had held a similar view centuries before, declaring that nothing exists but atoms and void. This notion was not taken seriously by large numbers of people, however, until the philosophers and scientists of the 17th century, Francis Bacon, Thomas Hobbes, Jonathan Kepler, Galilei, René Descartes. I never can pronounce these names. I'm going to figure out how to pronounce these names again, only to forget them. I know I've said it, heard the damn word name 1,000 times, and my MS is in the way. So.
Descartes.
That's right, Descartes. I don't know why I keep saying that. And let's make sure that Thomas's name was Descartes.
Hobbes.
So it's Hobbes. I knew it was Hobbes too. Lose my faith in my speech because of my damn MS. Okay, Francis Bacon, Thomas Hobbes, Jonathan Kepler, Galileo Galilei, René Descartes, Isaac Newton, and others adopted it as the basis of the new and rapidly growing physical sciences of the day. Their century, like our own, was one of discontent with traditional beliefs. Intellectuals, especially those committed to the new sciences, were desperately seeking escape from the straitjacket of religious dogmas handed down through the church from the Middle Ages. The new mechanistic worldview powerfully canceled out the earlier, more comforting view that saw meaningful connection between apparently discrete events. All right, another word I can't say. Which another word that I read before. Yeah, believe it or not, I have read it. But I just can't fucking pronounce shit. Discrepant. It's just like Google says, like, what, you can't pronounce the word? Are you that fucking dumb? And I'm like, yeah, I've become that fucking dumb.
Discrepant imaginaries about the built environment. In other words, how we...
Discrepant. It's gonna be a long fucking rating. Anyways. And I haven't even read anything really complicated out loud yet. Okay, especially the new sciences is desperately seeking to escape to new mechanism worldview powerfully canceled out the earlier more comforting a more comforting view that saw a meaningful connection between apparently discrepant events. It became impossible that coincidences which share no apparent causative agency could form meaningful relationships with each other. Instead, so-called synchronistic events could share only the relationship of cards in a deck, which after being thoroughly shuffled happen to fall beside each other or to appear in the same poker hand. All this change from a spiritual to a mechanistic worldview meant a change in the fundamental myth with which human beings explain their universe. Scientific mythologies. Widely held belief systems constitute mythologies, regardless of their scientific or religious origins. According to the historian and astute student of mythology William Irwin Thompson, myths provide answers to three questions. Why are we? Where do we come from? Where are we going? Along with the philosopher Ian Barrow, we would also add the question, what is the real nature of the world? That is, how and what is it formed? In the late medieval Europe, questions such as these were answered by a powerful mythological system. The grand mystic architecture of the creation, handed down from Aristotle and rewritten by Christian philosophers in the 13th century, involved a series of mutually enclosed spheres beginning with the earthly world below and ending with the divine empyrean sphere at the top. This vision is described by Dante in the Divine Comedy. Networks of resonance or sympathies formed interconnections throughout this system so that no event occurred in isolation. In this cosmos, meaningful coincidences were natural. For instance, someone dreams of a distant disaster before actually receiving news of it. Or three friends living in separate parts of a large city find themselves drawn to the same restaurant at the same time. A flock of blackbirds lands on a house where someone is dying. Howling dogs are heard in the distance. Such coincidences contain common resonances that run through nature and the human soul, drawing both outer and inner realities into shared patterns of meaning. The view of the world provided by religion allowed for the meaningful connection we today call synchronicity. It is also as if people in the medieval times told themselves stories about the universe which included synchronistic events and plot structure. Indeed, myths are stories. Aristotle's use of the word can be translated as plot, which tells us about the nature of the realities in which we live. Such stories are guarded in the unconscious, where we act from behind the scenes to precipitate the structure of our understanding of the world. As Alfred North Whitehead, the great English mathematician and philosopher, wrote, "In every age The common interpretation of the world of things is controlled by some scheme of unchallenged, unsuspected preposition. The mind of any individual, however little he may think himself to be, is in sympathy with his contemporaries. It is not an isolated compartment, but more like one continuous medium. The circumambient atmosphere of his place and time. Such presumptions are the stuff of myth. They are the lines with which the great narratives of reality are written. To the individuals that live them, however, they are invisible, as water is to a fish. They live in it and it supports them, but they take it entirely for granted. Needless to say, scientists are no more exempt from this state of affairs than anyone. Mechanism 17th century science brought with it new myths, which not only transformed the official science of the day, but also changed the maps of the world that each person carried unconsciously within. This science viewed the cosmos as a great vacuum filled with solid atoms that interact only with direct impact. The result, while highly successful for the emerging sciences of physics, astronomy, chemistry, and medicine, was devastating to a sense of individual belonging and connection to the cosmos as a whole. Eventually, society and even human nature itself were restructured also the same lines. People came to be seen as separate and distinct objects, connected to each other and to the natural world only where direct contact was possible. Older notions of sympathies were reduced to the status of mere superstitions. As time passed and human nature was seen increasingly through the eyes of new science, people took on a further characteristic of atoms. The word atom means literally indivisible, that which cannot be broken down or divided. That is to say, there is no access to its interior, if indeed it has an interior at all. Likewise, people came to be viewed increasingly as having no interior and were reduced by mechanistic science to objects driven entirely by external forces. Instead, there was nothing. As it emerged in the psychology of the early 20th century, behaviorism viewed human nature in exactly this way. Now, the experience of a living and vital interior in the essence of human subjectivity. It is this subjectivity, as it mirrors the world without and its own feeling, that it is the very essence of the human soul. As novelist wrote in 1798, the seat of the soul is where the interior world and the outer world meet. Where they overlap, it is in every point an overlap. The soul is the source of those characteristics we regard as most uniquely human: creativity and intuition and conscience. It was this soul, this melding of the outer with the inner, to which those in medieval times turned to wisdom. It was the soul that responded in sympathy to events beyond its immediate surroundings. The loss of the interior dimension of human nature reduced us to two-dimensional beings, cast about by the events on the physical surface of reality. It terminated our intimate bond with the rest of the cosmos. Thus, science discouraged us from looking into ourselves for the meaning of things. It especially discouraged us from looking below the emotional surface of our own perceptions for felt meanings and the very stuff that formed much of the wisdom of previous ages. Galileo asserted that science should look and see what is actually there. Yet, as physicist Jeremy Haywood points out, quote, for Galileo, only things which could be measured or to be counted as valid grounds for argument, and the language for describing them was to be the pure language of mathematics, free from human wisdom and whim. End quote. Haywood notes that this attitude, built into the foundations of mechanistic science, disclaims, quote, the human capacity to know things directly as they are. Fundamentally, it proclaims the inadequacy of man to grasp complete truth. In the mechanistic scheme of things, virtually all parapsychological events, telepathy, precognition, psychokinetics, become impossible. The official view on such unaccountable phenomena is what psychiatrist Alex Comfort, making reference to the great 19th century physicist Hermann Helmholtz, and thus the whole weight of the mechanistic science, calls the Helmholtzian physician. Even if it is true, I don't believe it. The notion that unlikely consciousness may actually be meaningful becomes absurd. Instead, the wondering about their meaning, we simply marvel at the laws of probability. While statisticians rub their hands at the prospect of explaining them away. But every major mythology, while closing the door on some possibilities, opens others. Mechanistic science is an example of the success of a particular mystic mode of consciousness that has been carried forward with great energy, dedication, and commitment by many people. Examples of other, if radically different, modes that have achieved success in their own spheres of endeavor are shamanism and yoga. Shamans, operating within the framework of their own mystic consciousness, travel to other worlds, act as guides to departing souls at death, heal the sick with methods that make no sense to physicians trained in American Medieval Association approved medical schools. The yogi, developing a mastery over the inner world comparable to the mastery of modern science over the outer, objective world may be visited by, I guess it'd be siddhis or powers, which appear to be miraculous. Neither shaman nor yogi finds reality limited by scientific theories, no matter how those theories might deny their experiences. The mythos of the mechanistic universe brings our attention like a searchlight onto the stage of sharply defined and causal driven lumps of matter and the forces, fields, and energies that move them. Physicists call this drama the particle play. The new science, however, took up only the notion that the atom is individually small and applied it only to the external physical world. The soul was either denied or forgotten. As a consequence, our cultural attention to this play has become narrowed to the point that we have come to overlook the vast penumbra of daily real-world events that surround the stage but are not easily made to participate in the drama. Among these are meaningful coincidences. The universe depicted by mechanistic science is entirely predictable. Everything is accounted for by laws of causation. There is no slippage. Newton's equations for the movement of the planets assumes a mechanical system of action which, once set in motion, requires nothing further to keep it moving. At first, it was assumed that God had started the whole process in the beginning of time, after which it continued on its own like a well-wound clock. Eventually, however, the notion of God seemed unnecessary and was discarded. When Napoleon Bonaparte asked Pierre Laplace why he had not dedicated a mathematical treatise to God, as was customary at the time, Laplace simply replied, "I have no need of that hypothesis." Ironically, the notion of causation that characterized Newtonian physics grew from much older ideas based essentially in a religious mythos. In the classical Greek and Roman world, the Socratic concept of the iron law of the cosmos expressed the image of the universe as the actual body of God, in which all parts followed absolute law. Later Christian ideas of divine law owed a large debt to this concept. Such ideas were mainly of religious and political interest during the Middle Ages, but later were applied to the physical world. Oh God, fuck. Descartes. Can't say the fucking word. This makes me so mad. It makes me so fucking mad that I have to go through this shit. Why do I have to go through this shit? Descartes. Why do and then I have the notion to publish all this on the internet, but there's multiple reasons for it. It's not about making a following. The architect of modern notions of causality based his thinking expressly on the conviction that God would hold himself absolutely to his own rules. His idea of God's immutable consistency formed the basis of all later notions of causality. The result was the mechanistic mythos of the Newtonian cosmos. This mythos presents itself an awesome and austere beauty, but at the same time robs us of a sense of wonder about the small events of everyday life. Improbable coincidences are diminished to the trivial. Even major scientific accomplishments are drained of their human and poetic dimensions. Years ago, the novelist Norman Mailer was asked to sit on a television panel during a live broadcast of the first manned landing of the moon. While the rest of the panel talked in heady fashion of the technological accomplishments represented by the landing, Mailer decried the total lack of poetry in the handling of the affair, an event that formed the beginning of time. From the beginning of time, was meant to fill our spirits with wonder and inspiration, had been reduced to technological egoism and running descriptions of moon rocks. Nevertheless, Newtonian physics and mythos it embodied was spectacularly successful. By the end of the 19th century, many physicists had even come to believe that all the basic discoveries had already been made. Some said that the future of physics was simply to adding more decimal points to existing data. Bright students were sometimes actually discouraged from choosing physics as a career. Lord Kelvin, a prominent physicist of the day, saw only two small dark clouds on the horizon. These were minor experimental discrepancies in the mechanical explanation of heat and light. As the total import of these two dark clouds unfolded in the first decades of this century, they reduced Newtonian physics to a convenient fiction, the new physics. During the first decade of this century, we're talking about the 20th century, the full implication of this experimental discrepancies became apparent in the publication of the General Theory of Relativity by Albert Einstein, and the publication a few years later of a complete quantum theory by Werner Heisenberg. Werner Heisenberg. Taken together, these theories and the experimental work that was to confirm them demonstrated the assumptions of Newtonian physics to be mere approximations of reality. As such, they remain useful to engineers, but their mythic power to project maps of reality began to erode. The relativity and quantum theories are now in process of creating a new mythos, a new typology of reality. This mythos is popularly termed the new physics, a phrase that refers more to its mythological structure than to any explicit set of assumptions it makes. According to quantum physicist David Bohm, both relativity and quantum physics share the common perspective of wholeness. Relativity views space not as a void of Democritus, a region of nothingness between solid atoms, but returns us to a vision of the universe as a continuous, unbroken fabric. Atoms are special local characteristics of this fabric. The cosmos is of a piece, not empty, but filled with itself, much as a painting is filled with itself. There are foreground and background regions, but the canvas is continuous. Quantum theory is holistic in quite another sense. It views all action as continuous and unbroken. An experiment involving several atomic particles, for example, is treated as a single whole process. The particular particles have no individual existence but contribute only to the total event of the experiment. It is the whole situation that the theory deals with, treating the parts as secondary and having no essential substance. Such notions are more compatible with synchronicity than was the mechanistic model of the cosmos. Synchronicity itself implies wholeness and therefore meaningful relationships between causal and unconnected events. In quantum theory, we recover the view of the world as an unbroken fabric in which seamlessly separate events do not occur in isolation, but in fact from pieces of interwoven into common tapestry. This was Pythagoras' perspective when he looked into the ripple pattern of the water to see beyond into the future of human affairs. It is this perspective that was lost in the aftermath of Newtonian scientific revolution. The mythic dimensions of relativity and quantum theory, however, are taking surprisingly long to settle in. Discoveries made earlier in this century, the 20th century, are only now beginning to be felt widely. Alex Comfort points out one important reason for this. Unlike Newtonian physics, the new physics gives us little to visualize. We cannot get a clear picture of it on our heads. The cosmos of Newton was easily imagined as a great celestial machine, a cosmic clock running effortlessly and eternally. The cosmos of reality is more obscure. It has 4 dimensions rather than 3 that are obvious to intuition, and time is given an equal status with distance. Only with effort and aid of projection diagrams can we get much of a picture of this, and then only in an inadequate way. Quantum theory gives us absolutely nothing to hang an optical hat on. It postulates the probability waves and indeterminacy and complementarity, the sound like a dialogues from through the looking glass. The pioneers of the old physics believed that they were discovering the divine plan of the cosmos. Their science and their worldview were one and the same. In other words, their science formed a clear mythology. Quantum physics, however, has especially failed to provide such clarity. As Comfort observed, the revolution involved in quantum physics has had absolutely no impact on the day-to-day worldview, even of people who work with it. Unlike the discoverers of the Copernican and Newtonian world, these people experienced no recording of the consciousness. They say, "How intensely interesting," and go home to dinner. Unlike its classical predecessor, quantum physics presents an open view to the world, one in which the outcomes of events are not entirely predetermined by fixed and inflexible laws. Quantum predictions do not dictate exact experimental results at all, but allow instead for a range of outcomes and of differing likelihoods. In this sense, quantum theory is probabilistic, mapping probabilities rather than specifically specifying events. Some interpreters of quantum physics have bemoaned this uncertainty, feeling that it robs us of an exact knowledge given by Newtonian physics. It rubs the sharp edges off reality, leaving the picture fuzzy. Einstein himself vehemently objected to the probability notion, saying that God does not play dice with the universe. Here Einstein refers quite literally to the idea of natural law, that natural law is God's inherent adherence to consistent behavior. Other views, however, are possible. The brilliant systems scientist Eric Jansik argued that it is precisely this indeterminate character of the quantum world that gives it the openness that was missing in Newtonian cosmos. The universe at each moment contains the possibility of the unexpected, the new, the even, and even the creative. Introduction. Creativity. Nothing is closer to the heart of the experience of synchronicity than the feeling that the world itself expresses creativity and synchronistic coincidences. Such coincidences often have more the feel of poetry than physics. One recalls the beetle arriving at Carl Jung's window during the discussion of the dream beetle. In the case of M.D. Fortescue, I don't know, Fortescue? How do you pronounce it? Fortescue, I guess. I don't know. Fuck. The plum pudding, one gets the sense of a clown or trickster standing behind the scenes. The mystic face of the mischievous god, dimly seen, looking from behind the shroud of coincidence. Here we pick up the thread of a major clue to the meaning of synchronicity, the notion that chance may express itself through the mystic theme of a divine trickster embodied for example in the Greek god Hermes, We will examine this idea in length in later chapters. Perhaps the open nature of quantum physics is related to a certain willingness of many quantum physicists to tolerate paradox and ambiguity in their own lives. Niels Bohr proposed the principle of complementarity, by which particles become waves and vice versa, depending upon how they are observed. He carried into his daily life the belief that human situations likewise had opposite and complementary sides. In an interview, he once recalled discovering that one of his children had done something inexcusable. He found himself, however, unable to inflict the appropriate punishment. It was then that he realized that you can't know somebody at the same time in the light of love and the light of justice. Instead, you must choose the context in which you will know another human being. The context of love, if you are, for example, a father or a mother, or the context of justice, if you are, for instance, a judge in the courtroom. You will know one or two different persons depending upon which you choose. Wolfgang Pauli, like Bohr, was one of the inner circles of scientists who founded quantum physics. He was acutely aware of improbable and creative coincidences in his own life. Arthur Cloister, perhaps the greatest explorer of synchronicity in recent years, gives an example that occurred during the period when Pauli was intensely involved in working on problems related to symmetry in subatomic particles. Pauli visualized much of the subatomic activity in terms of mirrors and their reflections, becoming virtually obsessed with mirrors. A friend wrote him teasing him about his mirror complex, but Pauli wrote back calling the legend of Perseus and Medusa. And the legend, Perseus was only able to slay the Medusa, read nuclear physics, whose appearance was so hideous as to turn man to stone. By looking at her reflection in his shield, at about this time, Pauli received a paper from a former student and turned biologist concerning a certain light sensitivity fungus. I guess it's Micus, the Greek word for mushroom. Shortly afterward, Pauli was reading a philosophical essay dedicated to Carl Jung about, of all things, the significance of the Perseus legend. It appears that after Medusa adventure, Perseus founded the town of Mycenae. Let me see how you pronounce Mycenae. Mycenae, I guess. All right, Mycenae. That's what it's, Mycenae. I assume, which owes its name to a Greek pun, for on that site Perseus dug up a mushroom, but he had to dig so deep that it broke. That a brook sprung up from the earth, which quenched his thirst. So They called the town Mykeene after the mushroom. It was said that Polly roared with laughter upon reading this. Cloister comments that this whole tangible web is only a small detail and cluster of coincidental events with which Pauli encountered in critical periods of his life. Pauli was well known among the physicists of Europe of what was humorous called the Pauli effect. His presence alone was sufficient to cause complex scientific equipment to misfire. Apparently, theoretical physicists usually cannot handle experimental equipment without breaking it, and Pauli was a very good theoretical physicist. George Gamow, himself a well-known physicist, recounted such an event that did not at first seem connected to Pauli's presence. It occurred in Professor J. Frank's laboratory and Göttingen and Göttingen. I don't even know how to pronounce that. So let's find out how to pronounce it. I want to. I guess it's Göttingen. Okay, I'm going to leave it at that. Göttingen. Now, I don't know if I'm right about that, but early one afternoon, without apparent cause, a complicated apparatus from the study of atomic phenomena collapsed. Frank wrote about this to Pauli at his Zurich address, and after some delay received an answer in an envelope with a Danish stamp. Pauli wrote that he had gone to visit Bohr in Copenhagen, and at the time of the mishap in Frank's laboratory, his train was stopped for a few minutes at Göttingen railroad station. Galmo comments, "You may believe this anecdote or not, but there are many other observations concerning the reality of the Pauli effect." All right, the soul of civilization. Certain prominent themes in science and culture of our moment in history open the doors of exploration to that which was unthinkable in the Newtonian cosmos. History, says William Irwin Thompson, is the story of the ego of the civilization, while myth is the story of its soul. Ego of today's civilization is still tied to the Newtonian age. The official representatives of technology continue to speak the language of absolute causality. The soul of civilization, however, is changing. Old myths are disintegrating, and to the shape of the next mythology will take, the great mythologist Joseph Campbell remarked, one cannot predict the next mythology any more than one can predict night's dream. For the mythology is not an ideology. It is not something projected from the brain, but something experienced from the heart, from recognitions of identities, behind and within the appearance of nature, perceiving with love of a thou where there would have been otherwise only it. This, as stated already centuries ago, in the Indian expansion, that which is enlightening flashes forth, makes one blink, and says ah, and that ah refers to divinity. Campbell speculates, however, that at a minimum in the new mythology, which is to be of the whole human race, the old Near Eastern decartilization, decartilization of nature by way of a doctrine of the fall will have been rejected. Here Campbell puts the roots of the notion of a lifeless cosmos in the ancient myth of the fall of Eden, in which only the lost Eden itself was sacred territory. In the new mythology, he suggests all of the cosmos will again be sacred, so that when lightning flashes and a settling sun ignites the sky, or a deer is seen standing alert, the explanation ah may be uttered as a recognition of divinity. It may seem from all of this that efforts to prefigure the next mythology are bound to failure. Nevertheless, certain broad mystic themes that are important to our topic emerge clearly enough to be outlined. These are discussed briefly in the following pages, though most are not new to us. They include, first, the idea of profound wholeness; second, the notion that at some fundamental level we are all interconnected; third, the concept of the universe as filled with life; and fourth, the idea that creativity is basic to the nature of the cosmos. All of the consonants with all are consonant with Campbell's thoughts. The idea of wholeness, central to modern physics, is emerging as a major mystic theme of our culture. It was first clearly articulated in this century, as early as 1926, by the South African statesman and philosopher Jan Smuts in his book Holism and Evolution. Smuts views the cosmos as formed of wholes, each interlacing with others to form increasingly larger interconnected tapestries. These structures are not static, but evolve towards increasingly inclusive and complex and even creative forms. This picture of a universe of interwoven and evolving wholes he called holism, after the Greek hollow, meaning the whole. So not hollow, but holo. I guess that's pronounced holo, meaning whole. One correlate of the theme of holism is the return of the medieval notion that all things are interconnected. This idea finds modern expression in biologist Rupert Skeldrake's theory of morphic fields, the networks of resonance that form webs of mutual influence beyond the usual limitations of space and time. We will explore Skeldrake's notion, so reminiscent of the old concept of sympathies, in later chapters. On the level of popular culture, however, the mystic notion of interconnection is seen in the recently fashionable story of the 100th monkey. This is a loosely reported set of scientific observations which, despite having been widely discredited, has risen to the status of a cultural parable. The story concerns a number of Macus monkeys. God damn it! I'm not giving up. If everyone else gives up, I don't care. But I'm not giving up because I have to do this. Maracas monkeys. That's what it is. And colonies maintained by the Japanese government. In his book Lifetide, The Biology of Consciousness, biologist Lyle Watson told of an energetic young female named Imu, who discovered how to clean sand from sweet potatoes by dunking them in a stream. Over a period of time, she taught other monkeys this trick, and the skill gradually spread. All at once, however, the rate of spread seemed to undergo a quantum leap, and virtually all the monkeys began to do it. Watson wrote, "Let us say, for argument's sake, that the number of potato washers was 99, and that at 11 o'clock on Tuesday morning, one further convert was added to the fold in the usual way, but the addition of the 100th monkey apparently carried the number across some critical mass, because by that evening almost everyone in the colony was doing it. And not only that, but the habit seems to have jumped natural barriers and have appeared spontaneously in the colony, on other islands, and on the mainland, in a troop of Fuboy FC Takasakayama. I guess that's the place in Japan. Despite the fact that Watson himself has admitted that this story is not based on sound observation, it has been widely repeated. Its appeal is strong, and it has been told and retold. Its popularity, however, is based not on fact but on its own visibility as a parable of wholeness. It tells us again in modern times that we are all connected, related to the mystic theme of wholeness and the return of a sense of the universe is filled with light. Smut's holistic vision of the cosmos is organic, with its emphasis on the evolution of ever more complex and even creative wholes, carrying the sense of a living, developing process. Such a process, of course, is antithetical to the Newtonian vision of a machine that runs relentlessly and unchangingly for a time. Holism is more consonant with the medieval experience of the cosmos. the experience based on the notion that living forces animate all of nature. As late as the early 17th century, Johannes Kepler, or Johannes Kepler believed that the earth itself was animated by an inherent spiritual nature. This idea returns us to us in our own time as biologist James Lovelock's Gaia hypothesis, after the Greek earth goddess Gaia, which states that the earth as a whole exhibits the properties of a living organism. The return of the sense of life to a cosmos brings with it a return of the possibility of creativity. Smolt's concept of holism included the idea of the new and unexpected thrown up in the evolution of complex wholes. At the turn of the century, even before Smuts, the French philosopher Henri Bergson had suggested that the notion of emergence as creative elements that unfold in the process of evolution. As we have seen, a similar idea is embraced by the openness of quantum physics itself, an openness which allows the possibility of the unexpected in each new moment. And David Bohm uses the term implicate order to describe a holistic quantum process which underlies ordinary reality as we experience it from day to day. He discussed its implications for wholeness and creativity in an interview. The entire notion of wholeness, creative wholeness, is built upon the implicit order. It would be similar to the flash of creative insight in our own mental experience. The general tenor of the implicate order implies that what happens in our consciousness and what happens in nature are not fundamentally different in form. Therefore, thought and matter have a great similarity in order. We might extend that idea, saying that the creativity and insight that we have may also have its parallel in nature. In Bohm's connection of mental and physical processes, we begin to see the return of a sense of wholeness, life, and creativity to the universe of physics. A sense that brings with it the return of human meaning to the cosmos itself. We begin to recognize ourselves as truly at home in this cosmos, as was true before the rise of mechanistic science. The larger dimensions of the world are again experienced in terms meaningful to the human spirit. The language of this experience is the language of myth, a language that bridges the space between consciousness and unconsciousness, a language that speaks of meaningfulness of events both within the mind and within the greater world in which each of us lives our day-to-day lives. Myth draws us into meaningful relationships with our entire world. an arena that encompasses both our own minds within and the objective events of the world without. Synchronicity must be understood within this entire context, lest it be trivialized into statistical anomalies and stripped of its human meaning. Like myth itself, synchronicity bridges the gap between the conscious and the unconscious, between the world of mind and the world of objective events. Not surprisingly, synchronicity is therefore ultimately best comprehended in the language of myth. We will seek our understanding of synchronicity in the pages of science and in the hints of mythic meaning found between the lines on these pages. We will explore various perspectives of contemporary physics, biology, and system theory with an eye to the literal and the eye to the mythic. We will then look to the wisdom of earlier ages, when myth was the predominant form of human understanding. From this original wellspring, we will seek a deeper psychological and spiritual comprehension of synchronicity. We will learn particularly from the trickster, Hermes, and Greek mythology, Mercurius in medieval alchemy, Coyote and Native American mythology. Of all the mythological characters, it is the trickster who is most associated with chance and synchronicity, who is the bearer of good and ill fortune, who stirs the sands of fate and melds together glad and unhappy chance and patterns guised only in the gleam of his eye. Part 1, Synchronicity. And the proper cover for this book is this one. That's the one I've been using. Through the Eyes of Science, Myth, and the Trickster, Synchronicity by Alan Combs and Mark Hollins, with a new foreword, which we read already, or I read.